Make sure yesterday everything was good. Hopefully you agree with me. Everything was kind of easy yesterday. So 10.2. Does anybody have any questions?
Yeah.
Good.
Okay, I have a question on number 16.
Right here,
Uh,
I'm trying to find QPS. So Q. Now again, they should have just said QS, but we're just finding that. Do you agree?
right.
So how many degrees is that?
That would be not 50. Well, I mean, not 90 degrees. 80 degrees. No, 90. 110. 110. Is it 130? 130.
How did you get that?
I added 90 plus 20 plus 20.
Why is that 20?
You just I don't know what PT is.
Okay, so if this is 60
Right.
from here to here, that makes this how much?
That makes that 150. And that makes that 170.
Why is it 150?
Because 60 plus 90.
Halfway around the circle is 180.
Right.
So if this is 60, this is 120.
Oh, okay. That whole
So then QT is how much?
so then QT has to be 140.
Yes. I mean QS.
Yeah,
I'm sorry.
yeah,
QS is 140.
Okay.
All right, so ZQ is 7. So that's a radius, right?
So ZQ is 7, and then PZ is a radius 2. And
So,
they're all radiuses.
okay, whatever, just tell me how to solve the problem now.
Okay, then QPS would have to be 75.
How do you get that?
I multiplied 7 by all the radii, so 1, 2, 3.
Look, stop. Were you here yesterday? Okay, we're just doing part of the circumference.
Okay, so you want me to just like...
I want you to tell me what the circumference is.
Okay, the circumference would be that times pi. So...
How about 14 pi? How about 14 pi?
Okay.
How did I get that?
14 pi...
Because circumference is 2 pi r.
Right. So 2 times the radius times pi.
That's it.
Okay.
That would be the whole circumference.
Right.
I don't want the whole circumference.
You want to divide it by 7. So
I want a fractional part of it. That fractional part would be 140 out of 360.
and...
Okay?
Okay.
Now it's just a matter of reduce, right?
14 so that's 7.
So now we can,
7, 18.
I'm not sure that's correct.
14 and 36.
So this could be 7, this could be 18, this could be 9, this could be 7. Isn't it 49? Did anybody else get 49 pi over?
Yes, 49 pi
Over 9?
Okay.
Right?
Okay, I get that. 14 pi multiplied by 140 over 360.
Yeah. All right. Yes.
You don't know what it's 5.
Yeah, was everybody okay? Now listen, the only reason I'm asking about 17 is because 17 is on the ERBs quite a bit. Converting from your percentages to find the central angle, right? That's not a big deal. Did I agree with that? Right? So it says if you were to construct a circle graph of the data, how many degrees would be allotted for each category? Well, how many degrees are in a circle? Right, is everybody okay with that? So less than 1 hour, that would just be 360 times what? 0.08. Is everybody comfortable with that? Do I need to do anything more?
No.
Right? Okay. So now let's take a look at the word problems. Those are important. All right, which one do you want me to take a look at? All right, let's look at 5. All right, Lucy has to buy a new wheel for her bike. The bike wheel has a diameter of 20 inches. If Lucy rolls the wheel one complete rotation along the ground, how far will the wheel travel? Anybody have an idea? It is the what? No, definitely not. It is the circumference. The wheel travels one revolution. One revolution, listen to me. One revolution is the same as one what? Circumference. Right. So the circumference of her circle is what? 20 pi. Right? And 20 pi is equal to one revolution. That's super important what I just said. One revolution is the same as one circumference. All right? So if you were to roll a wheel down the road, if you let the wheel rotate one time, it will be one circumference. That's the answer, 20 pi. All right, so it'd be 20 pi inches down the road. All right? Now it says, if the bike wheel is rolled along the ground so it rotates 45 degrees. Now I tried to tell you yesterday, 45 degrees is what fractional part of the circumference? 1/8, right? 1/8. So this would be 20 pi over what? 8, which is the same as? No, which is the same as what? 5 pi over 2 inches. Divide those by 4. You can say 2.5 pi, I don't care, but you'll see, you never do decimals. You know, listen. C, here we go. If the bike wheel is rolled along the ground for 10 inches, through what angle does the wheel rotate? 180. Is 10 half of the circumference? You guys are killing me on that. Your mistake was you thought 20 was the what? Circumference. 20 is not the circumference. What is the circumference?
20 pi.
20 pi. Look, guys, look how simple this is. One circumference is what? 20 pi. You've traveled what? No. You've traveled 10. Right? So you have traveled what? 1 over pi, part of the circle. So you have traveled how many degrees? Very good. 360 divided by pi degrees. That is your answer. What? I reduced 10 over 20. Oh, it should have been 1 over 2 pi. Thank you. So that would have been not 360, but what? Thank you very much. Good job. Everybody okay with 180 degrees over pi? Well, I just reduced. Right? So again, let me try to make myself clear. Because I understand this is the fractional part of the circumference. So there are 360 degrees in the circle. So I just multiplied that by 360.
Okay.
You agree? Yes. Yes, I can, but I'm asking about C. Look, let that sink in. That's a really good problem right there. Really good. Now, what makes it difficult is the fact that I'm using what? Pi instead of approximately. Do I agree with that? But you can say this is approximately what? 60 degrees. How do I know it's a... Just divide by 3. Right? Think of pi as just 3, and it's easier to picture now what we're talking about. Because, let's look at this carefully again, because some of you, I'm not sure if you're understanding me. So everybody do on their calculator 10, oh, this is going to be interesting. Everybody do 10 divided by 20 pi, and somebody tell me what they got here. Very interesting.
1.57.
How much?
1.57. So
Hold up. Shh, shh, shh. 10 divided by 20 pi again, Mr. Davis, is what?
1.57.
Man, anybody agree? Now, so do you see my point here, guys? I'm trying to show you now, look, don't let the calculator outsmart you. If you type in on your calculator 10 divided by 20 pi, you got the wrong answer. You see what I'm saying? You have to do 10 divided by that, or, please pay attention, you have to do 10 divided by 20 divided by pi. That will save you from using the parentheses. Now look, guys, I'm really, to me, facts don't matter because I can look up facts. Everybody hear me? I can look up facts. Everybody okay with that? I can't look this problem up. If I say what is 10 divided by 20 pi, you can't do anything if you don't understand. Right? I need everybody to look and make sure you understand. When I say 10 divided by 20 pi, that's the same as 10 divided by 20 divided by pi. It's not the same as 10 divided by 20 times pi. I'm trying to get that sink in. I'm trying to get you to have, whoa, okay, I understand what he's saying. You understand what I'm saying or not? I didn't think so. I can tell. All right? This is doing 10 divided by 20 times pi. That's what that's doing. I'm doing 10 divided by 20 pi. So you could do 20 times pi and get 60. 10 divided by 60 is what you're doing. Not 1/2 times pi, which is what he did. The reason why I know that is because half of pi is about 1.5. You understand me now? All right. So again, that is one of the most common mistakes that people put on standardized tests, and they let you use calculators on because they know you're just going to make a mistake with that. You understand it now, what I just said? All right. Hopefully you understand. All right. So everybody's good with that now. All right. So you asked me about which one quickly. All right. Let's check out number 3. Yolanda has divided a circular apple pie into 4 slices by cutting the pie along 4 radii. The central angles are blah, 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 blah. What exactly are the numerical measures? So the angles add up to what? 360. So 3 plus 6 plus 4 plus 9. 18x equals 360. That's just mental math. X equals what? 20. So yeah, we got it. We're used to them. All right. Anybody else have any issues? Agreed? All right. Now again, for me, this chapter so far is pretty logical. Right? You know circumference. All right. Now we figured out what the arc length was. Very easy. We know an arc measure. You measure an arc with what? Degrees. Very important. All right. You also measure the length in units. Everybody with me on this? All right. Very important. Very easy. Very easy. All right. So I think the next unit, 10-3. Here we go. Again, basically all I'm doing is giving you rules. All right, I'm giving you rules. All right. So now let's talk about the rules for 10-3. Is everybody up and running on 10-3? Let's go. Hustle up. Okay, everybody good? All right, let's talk about it now. Does everybody agree? RS could be referencing the arc, or it could be referencing the chord. Do you agree? That's why there are symbolisms for it. RS, that is obviously the arc, and then RS is the chord. All right, so what do you think is true if I told you that RS is equal to TV?
The arc is the arc.
The arc. That's exactly correct. To me, again, it's just logic.
The same part away from the
Exactly. And eventually we'll talk about that. If the chords are equidistant from the center. All right, we'll get to that. All right. But if the chords are equal, then the what? Arcs are equal. If the arcs are equal, then the chords are equal. All right? Very logical. The chord is just any line segments whose endpoints are on the circle. All right, so the diameter we say is the largest chord. All right, but a chord is just simply a segment whose endpoints is on the circle. All right, so now let's go through real quick. All right, so how do I figure out what x is? How many degrees is x? Brilliant.
Oh, you can do 180, 360 minus 64 divided by 2.
Exactly.
148.
Come on. Everybody happy with 148?
Yeah.
Come on, guys. Come on now. Very simple. All the way around the circle is how many?
180.
360 minus 64 divided by 2. Right? It's 3 arcs. Two equal arcs. You with me on this? All right, here we go. What's x? Obviously 116. Very good. All right, let's review that. Why is that, Ms. Stern? Because it's called a what type of angle? It's called a what angle? Someone help her. Yeah, equal angle. That's called a what? Central angle.
Central angle.
Right? It's called a central angle. All right, the reason it's called a central angle is because the vertex is at the center of the circle. And so that angle is equal to the measure of the arc. What? All right, here we go. Check out number 3. 82. Brilliant. Okay, number 4.
So just the 360 minus
135 degrees. Number 5. Mental math.
7.
Everybody good? Any questions? All right, 6. Come on, mental math. X equals what?
Yeah, X equals 2.
X equals 2, right? Any questions with that? All right, question number 7. Yep. X equals 2 again. All right, now look at question number 8.
Is it just the same thing separated into circles?
And that's a good point. So look up here. So it's saying here that the circles are what? The circles are the same, correct? So if the circles are the same and the arcs are the same, then the chords are the same. All right, now again, that's obvious, but just kind of look it over and make sure you see that. Right, if the circles are exactly the same, it doesn't matter where I put the arc on what circle, correct? Right.
X equals 6.
Yeah, actually, so.
So x equals 6. Over here, same principle. You're looking up, they tell you that the circles are equal. Now, I'm not sure if that's correct, right? Because I have 198 and 162, so what's the problem?
198.
Yes. So arc YZ is how much? 162. You with me on this now,
So you're
right?
going to set it equal to
There you go again. So you got what? X equals, come on, mental math, 13, right?
Yeah.
X equals
Yeah.
13. You were right. Once today, good. Okay. Very true. All right. Here we go. It says now, in a circle, if a diameter is perpendicular to chord, then it bisects the chord, which kind of makes sense if you just look at it. All right. If you draw yourself an accurate picture, you will see, even if you didn't know that, that looks what?
True.
It looks true. Now, how do we know it's true? Because if you draw the radii that connect, you can see how it makes equilateral triangles, and then you could prove that by, your side angle side.
So you know how like trigonometry, like triangle, geometry, and just like circle.
Geometry is just kind of a study of shape.
So all of those angles are right.
Well, this is right here. All right. So this is equal, that's equal. You see what I'm saying?
Oh, okay.
Right.
It's not entire like square like.
So then could we prove that W R?
Hold on. Let's just go through this now real quick so we don't have a lot of homework. Just listen to me now. If it's perpendicular, it bisects the chord. All right. If it's perpendicular, it bisects a chord. In a circle, the perpendicular bisector of chord must be the what? The diameter. All right. So again, they'll get to some pictures later on. But if you have a chord and you draw the perpendicular bisector here, and then you have another chord over here, and you draw the perpendicular bisector here, what did I just find?
The midpoint.
I actually found something more than the midpoint. I found the center of the circle.
No way.
That's not what the
You found the center of the circle.
circumference.
You found the center of the circle. Because both of those are the what? Both those are the diameter.
Oh.
All right, both those are the diameters. All right. So again, keep the rules now. Listen to the rules now. Make sure you hear them. All right. In a circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center, which again, hopefully makes sense. All right. If you were to draw a circle and you would say, for example, this unit is 1, and then you would come down here and draw another one and say from here to here is 1. Then the chords have to be equal. If they're equidistant from the center of the circle, the chords have to be equal. All right? So now let's just apply that real quick. All right? In circle, the radius is 13. And RS is 24. So if RS is 24, then 12 and 12. Does everybody agree with that? And it says that the radius is what? 13. Now, here's what I want to show you guys. If the radius is 13, and this goes for a lot of the SAT tests, all right, I want you to hear me what I'm telling you right now, is most of the time the problems are hard until you draw in the radius. So watch what I'm saying. So if I draw from here to here, All right, what is that distance right there? 13. Now the problem is simple, right? Because now from here to here is 5.
Oh,
And then that makes this what?
Oh.
8.
Wait.
All right, so
Because
the
from the middle
problem
of the-
is very easy.
Oh.
Listen, if you're having trouble in a circle measuring something or finding something, think about drawing a radius in somewhere. All right, that usually will answer the question. All right, look up there and make sure you understand what I just did. All right, and again, if you remember the Pythagorean triples, it was very easy. Sam, what?
Oh, I'm just trying to. I get.
Because it's a triple.
Oh.
5, 12, 13. Or you can do a squared plus b squared equals c squared. All right, again, those numbers, 5, 12, 13, 3, 4, 5, 8, 15, 17, 7, 24, 25, come up a whole bunch. All right, so if you can remember those, all right, it makes life much easier. Yes.
So is 8 from the Pythagorean?
No, 8 is from the fact that 8 plus 5 is 13, because that is a radius. Do you hear me? All right.
And
So, did I answer the questions now? RT is 12, PT is 5, and TQ is 8. All right, that's actually hard. All right, that problem right there is hard. And that's common on the SAT. All right, very common on standardized tests. All right, so let's go over here. If the diameter is 12, now if the diameter is 12 right off the bat, I would put this to be 6 so I could visualize.
You put BA.
And then CD is 8, correct? So then I would put a 4 right there. All right? And then arc CD is 90, right? Which means this has to be what? 45 and 45. Now, if I wanted to, I would just continue there. All right? Is everybody with me? So now they want to find DE. All right? Arc DE, we already said was what? 45. Now I want FD. We said was what?
6.
Wait a minute. I think it's 4.
Oh.
Now we want from A to F. All right? Now again, the reason why that's hard is because you didn't draw in the what? The radius. And that radius is how much? 6. So you should say this right here is 36 minus 16, which is 20. Square root of 20 is 2 radical 5. Thank you, guys. Catching up. 6 squared. A squared plus B squared equals C squared. I see a right triangle, that's why.
So then it's a 45, 45.
Nope,
No.
nope.
Why is it not?
It's A squared plus B squared equals C squared. What? Wouldn't?
CD was 90.
And BE bisects.
Good? All right. All right, let's move forward now. So, AF we said was 2 radical 5. All right, let's look over here now. Okay, so it says TS is 21 and UV is 3x, so that's obvious. X equals 7, right?
Yeah, how do you know that?
How do I know that? Somebody tell me. Because you're
Oh.
equidistant. All right. If chords are equidistant from the center, they're equal. All righty? All right, over here. If CD is congruent to CB and GQ is X plus 5, so those are equal. Agreed? So mental math, X equals,
11.
right, I like it.
Yeah.
X equals 11 halves. Everybody okay with that? All right, again, I'm just saying rules. All right, all it is, just rules. All right. Now, practice the next two. Very easy. All right, very, very easy. All
Our
right,
next 2 pages, the next 2 problems.
very good. The next 2 pages. You're welcome.
Not homework. At least there's no homework. We have